button. Off it goes. All right, so today is the last lecture on Scratch. It's programming day, but this is the last time we're going to learn about Scratch. Isn't that exciting? I'm excited to teach you the next language, but let's see how much we can get through this lecture. Might have to give you the abridged version today. All right, so the first thing that I want to talk about is just how to write a program. Right? We've been writing some. I've asked you to do things in a certain step-by-step way, but eventually, like your boss one day is going to ask you to write something, and they're not going to give you steps. So how do you write a program from scratch? How do you think about it? How do you look into it and figure out what you need to do? So here is like kind of the program creation process. This is what I think about when I'm writing a program, and I believe that if you follow it, it will all work out. Is this too large? Let me change this. No, that's too small. Good old PowerPoint. All right, good enough. So, all right, if you are asked to write a program that, I don't know, does some fancy computation for your boss one day, you need to think about these three things, I would say. So first of all, you have to understand what's being asked of you. Like, are you trying to generate a spreadsheet? Are you trying to make an animation or a game or something like that? So figure out the problem itself, and that will lead you into talking about what are the concepts involved in making that. Concepts involved. Like, do I have to read a bunch of files? Do I have to set up the keyboard to interact with the user? Stuff like that. So that will be the first step. And then you play a game with inputs and outputs. So you need to think about, what are you getting? What is the input to your program? How do you start? Is somebody giving you a file and you're spitting out a new one? Or are you getting key presses? What's going on? So what are the inputs to the program that you're writing? What will the user give you? What will the user give you? So that's very important. And then finally, what are the outputs? So what are you generating? Are you making a file? Are you making a game? Are you making a video? Are you making a picture? What is the output? What's the answer that you're giving back? What is the answer that your program gives back? And I'll put answer in quotes because maybe it is a game that you're making. It's not just like a number that you're computing, that your program gives back. And so if you think about a question that's put in front of you by somebody in this way, you can solve the problem. Think about how you might make a strategy to take those inputs to those outputs. That's really all a program is. You're getting something from the user, you're messing with that stuff, and then you're somehow transforming it into what you needed to give back. Right? Simple, right? So that's pretty much all a program is. At the end of the day, you're making an algorithm. You're making a sequence of steps to do something. That's all. Right? So that's how you're going to make a program. And so I want to give you a bunch of examples of doing that, of following this process, these three steps kind of, and then I'll ask you to try in just a few slides. So here is our first problem. Let's do a computational numerical problem, what computers were invented for. Let's calculate n factorial, where we get n from the user. All right? So the user gives us 5, and we need to calculate 5 factorial. That's the thing with the exclamation point, right? That's 5 times 4 times 3 times 2 times 1. Yes? So, all right, let's think about things. What is our input? What are we getting from the user? We're getting a number from the user. The user's typing 5, and we're putting it somewhere. So n is 5. Cool. Well, we can save that away in a variable maybe. And then what are we trying to compute? What's the output? We're trying to show the user a number right back. The factorial of that 5 or whatever they gave us. All right? And then we can go about trying to take this 5 and output 5 factorial, which is apparently 120. I did that ahead of time. So that is our goal. So we got to think about the problem. And the problem itself is just, all right, we have a number. How do we find the factorial of it? And so you have to think about, all right, what is the process for doing that? So how am I going to compute a factorial? The normal way would be all right, using this 5, try and make another variable and start multiplying 5 into it, 4 into it, 3 into it, 2 into it, 1 into it. That's going to be the game. So how are we going to compute it? And if you think about it long enough, here's the way that I came up with. Let's make 2 variables. So we're getting the number from the user, and then we're also going to get something to output in. So let's make another variable, call it out. That will remind us that we're going to give that back to the user one day. And let's start out at 1, because now I can multiply 5 into out, and then suddenly it holds 5, and then 4 into out, and now it holds 20, stuff like that. All right, so let's keep multiplying n into out and then decrementing n, because like I've got the 5, then the next thing I need to multiply is the 4. So this is kind of the process. Multiply 5 into out first. So now out is itself times 5. Now it's holding 5. And then decrement n, make it 4. So now when I multiply in the next round n into out, now it's going to hold 20. Do you see how that process is going to lead us to the factorial answer? So now it's 20. Decrement n, that's going to be a loop, right? We're going to repeat this stuff. So, all right, take n, multiply it into out again. So now it's 60, cool. Keep on multiplying, decrementing n. I need to multiply 2 now. That's part of the factorial. 2 into the out variable. Okay, 2 times whatever's there is now 120. Make n 1. And technically you could stop here because like times 1 doesn't change anything. But let's do it anyway. It's like, all right, 1 times out, that's still 120. And then decrement n. And this is where I want to stop, right? Because the second n hits 0, I do not want to multiply 0 into out because that would make the whole answer 0. I wanted to stop before that. So there's my stopping condition to my loop as well. So if you think about it long enough, this is kind of the strategy that you might come up with. So once n is 0, we need to stop. Stop doing this because then we don't want the output to be 0 and output whatever out holds. All right, so that's kind of what's going on there. And then as you're implementing this, you might notice like maybe if you don't trust the user especially, what are some other sub-problems, some problems inside of the problem that you see? Like, okay, what if the user gives me -5 to compute the factorial of? There is no such thing as -5 factorial, right? So in that case, maybe we should notice that and output an error message, or maybe we just trust the user to always give us a positive value. It depends on the program. So that is something we have to think about still, okay? So that is the idea. And this whole process of putting stuff into another variable, like working on it one thing at a time, is called accumulation. We're accumulating an answer as a product, so we're starting it at 1 because we're multiplying into out, right? So that's that term. I think I've said it once before, but let's implement this. Let's go to scratch.mit.edu and do it together. All right, let's go. Let's click Start Creating. And so, all right, first thing we need to do is get input from the user, right? So we need that number. What do we want to compute the factorial of? So we better ask for it. So let's do that. Let's go to Events. When green flag gets clicked, what are we doing? The very first thing we got to do is ask the user for that number. What is n? Enter n. I don't know. Enter n and wait. Okay? And then we get it, right? We're going to get it from the user, and it will be placed in this answer variable. Like if they enter 5, it will be placed inside of answer. But I do not want to work with the answer variable because I cannot change answer like I can with a normal Scratch variable. Like I can't decrement it. It's just whatever you get from this ask block gets shoved into answer. So I need to make my own variables. Let's make 2 variables, call it n and out. So I'll rename the default one to like n, and I'll make another one called out. So now I have them both. And then I can take this answer, whatever it was, maybe it was 5, and then I can set n to that answer. Now n is going to hold 5, and now I can work with n and like change it. I have these change blocks, right? So if I set n to be 5 and run it, I'm placing it in answer into n, so now n is 5. Does that make sense? Any questions about this so far?
Wait, how did you set n?
I use the set n block. Set this variable to 0. Question? Oh, sure. Yeah, just what's going to happen when the answer block gets run. So it's the ask that is like hooked into the answer variable. Once I ask the user for something, nice. Once I ask the user for something like 3, it's going to always place whatever I just typed into that special answer variable. But I can't change answer unless I ask the user for something else. So I want to put it into n so that I can now mess with n. Does that make sense? That's the goal. So, all right. So now n holds answer, and I can kind of do this loop. So I want to repeatedly, so I'm going to loop in some way, like repeatedly put n into out, multiply it in, and subtract 1 from it. And I want to stop once n hits 0. I want to keep going until n hits 0 because that ruins everything if I put 0 into the output, right? Can't multiply a number by 0 and have it be the old number still. So let's do that. Control, let's have a repeat until loop. So we repeat until n becomes 0. So we want to keep working, right? We want to keep doing this process as long as n is bigger than 0. As long as n is bigger than 0, do all this. But the second becomes 0, like we are done. That stops the loop. So repeat until n equals 0, let's say. So let's take an n. Let's take an equality check from operators. And repeat until n is 0. All right, what am I doing? I'm multiplying out, or multiplying n into out, shoved in there, multiply out by itself and n, and then I'm decrementing n. All right, so set not n but out to itself times n. So it's kind of a long process in Scratch, a lot of things to drag. So set out to itself, whatever it is right now, times that new value of n that I want to put into it and multiply. That's a piece of the factorial. And then I want to get ready to multiply like the 4 into out, the 3 into out. Let's decrement our n so that I have a new value to set there. So I can do change n by -1, or I could have done like set n to itself -1, whatever you want to do there. But that's kind of the process. Any questions about that so far?
I'm going to set n to variable.
Making some sense. All right, so let's try and run this. Let's say, all right, so if I want 5 factorial, it goes off and does stuff very fast, but out is 0. What? Let me have it wait for a second. Let's go into down here in events. Let's have it wait a second in between loop calls, so loop body runs. So set n to be 5. It's multiplying. It's setting n 3, 2, 1. It's multiplying in and out, but what's wrong right now? The answer is 0. Does anybody see the problem? There's something I forgot to do. I'm going to get 0 no matter what. So like, all right, 4 factorial. 4, 3, 2, 1, multiply it out. Just stays 0. I'm trying to accumulate an answer. And out is right now 0. Can I multiply something into 0 and get anything normal back other than 0? No, I'm kind of stuck there. So I forgot to initialize out. You see that? So out better have started at 1 so that I can put stuff into it. The default value of a new variable you make in Scratch is 0. And so I need to change that. I need to initialize out. So at the very start, I better set n to answer and also set out to 1. So it's like a new round. Because now once it works, like if it makes 120, I don't want to multiply into 120 the next time I run the program. I want to initialize out to some new value. All right. So that is going to give us accumulation. You can see out getting bigger and bigger, multiplying n. And we stop when it's 0, and out holds 120. Look at us. And so maybe the real thing, like this is just for us, the programmers, these checkboxes. Maybe we should have the Scratch cat just shout out the answer or something. Say out for 2 seconds after you've computed it. Something like that. That could work. But that's going to be the process. Multiply and out, watch it change, and then voila, 120 is the answer. Or multiply, start with 3, 2, 1, 3 factorial is in fact 6. It seems to be doing it right. Okay? You see how I got to this point? Does it kind of follow from the diagrams? Any questions about that? Because now's the time you ask yourself, like, is that enough? Am I done? If we do not trust the user, watch what happens if like I enter -5 and ask for the factorial of -5. It's like, all right, multiply -5, -6, -7 into out until it gets to 0. I'm subtracting. So is a negative number ever going to get to 0 if I subtract from it? Just watch out change, and it's getting huge right now, and it's oscillating between giant positive and giant negative numbers. It's never going to end. So I have an infinite loop right now if the user gives me a negative value, and I probably don't want that. So that is a solution that we could change. Let's add a sub-problem answer here. Let's be like, if this ever happens, if we're ever asked to find the factorial of a negative number, how about we just like stop the program or yell at the user, something like that. So like before we try doing this, because it might not work, it might be an infinite loop. Before we try, how about we check if the user gave me a bad value for n, then I better stop. So if n is like negative, if n is less than 0, let's stop all this. No thank you. Be like, let's shout at them. Let's be like, cannot do the factorial of a negative number. I can't find the factorial, and factorial doesn't exist for negative numbers. Something like that. And then also, we don't want to have the loop start right now, so let's stop the program in control. There's a stop block. So like, stop everything. So now, if the user ever gives me a bad value, like -5, it's like, okay, factorial of negative numbers does not exist. And then it stops the program. So like the lowest number now that it will get to the rest of the program would be the factorial of 0. which is going to skip the loop and just like give back out, which is 1. And the factorial of the factorial of 0 is defined to be 1, so that works out. So that is, if I zoom out, that is a correct program, I would say, that calculates the factorial of a number by accumulating that answer into another variable. How are we doing? Questions about that example? So I have a more complicated one with 2 variables next. 2 variables and a third out variable. We good? All right. So how about this problem? Let's sum the numbers. Let's sum a bunch of numbers from n1 to n2. So like the user asks me to sum all the numbers from 2 to 7. Then I want to go and I want to compute 2 plus 3 plus 4 plus 5 plus 6 plus 7. That's kind of the answer that I want. Sum me all these numbers from n1 to n2, where n1 and n2 are what we're getting from the user. And so that's an easy answer for what are the inputs, right? So we're getting 2 numbers from the user, n1 and n2. We're going to put them into variables. Like we got 2 and we got 7. And what is the output? We have to figure out the sum of those numbers, starting from here up until here. All right, that's what I need to print out. It's another number at the very end. And then, all right, let's go to the problem itself. What do I got to do? I got to take n1 and n2 and somehow go between them and add things. Maybe I need to accumulate another time. So that's an issue, all right? So how can I do that? So we got to go and figure out how we can compute the sum. And then there are some problems that we might have to solve along the way. Like, what if the user gives me a bad set of numbers? Like, what if the user asks me to sum all the numbers from 7 to 2 in that order? And there are no numbers between 7 and 2 increasing. So we have to figure out, what do we want to give back in that case? Do we give back 0 because there's nothing there? Do we want to yell at the user? Problems to solve, right? But it's up to us. And yeah, so let's figure this out. How are we going to solve the main problem at least? I got these 2 variables. I need to somehow compute the sum from n1 to n2. So, all right, if I'm summing things, I need to put the answer somewhere. So let's make another out variable. Let's do that. And I'm going to keep adding into it, right? So I'm accumulating an answer and I'm adding into it. I don't want to start out at 1 or 42 because then the answer would be offset by something. So let's start the out variable at 0. It's another accumulation process. So if I'm adding things, I don't want to affect the answer. So I want to start it at 0. All right. What do I do? I guess it's logical to first add the 2 into out. Where is the 2 right now? It's sitting in n1. So maybe I can add n1 into out. That could be the first step. Now it's 2. Okay. And then I want to add the 3 next. It's easiest to get from the 2 to the 3 and not go using n2. So how about we use n1 for this whole process? Let's take 2, make it 3, because that's the next number I want to add into out. Let's try that route. Let's increment n1. Now it's kind of I want to sum all the values from 3 to 7. That is kind of the rest of the problem. Seems to be working. So let's try it that way. Let's put 3 into out. All right, now it holds 5. Let's increment n1. Now I want to go, and 4 is the next value I want to add in. Okay, is this still working? Put the 4 in. Now it's holding 9. Make it 5. Put the 5 in. Now it's holding 14. All right, put the 6 in. Make it 6. Put the 6 in. Now it's holding 20. All right, make it 7. Put the 7 in. That's the last number I want to add into out. That seems to be doing the right thing. All right, now it holds 27 once I shove that into out. And that's the final answer. If I keep following this process, I might make n1 8, and that's too big. I don't want to add 8 into the answer. So maybe once the value gets bigger than n2, so that's not changing, that's the last number I want to look at. If n1 ever gets bigger than n2, then I know I'm done. That could work. I think that's the idea. So we need an output variable. It started at 0, and we want to add n1 into out as long as it's less than or equal to n2. So the second it and also increment n1, so we have the next value, the 3, the 4, to add in. We want to repeat all of this until n1 gets bigger. So repeat until, another repeat until block. Repeat until n1 is bigger than n2, because then I've added all the values I need to add. I've gone through the whole range and it's happy. Okay? Does that process make sense, at least in English? Kind of see how we might translate that to code? That's going to be the next step. All right. So I'm getting 2 numbers from the user now. Let me save this so that you have it later. I will clear it all out. So, okay. When the green flag gets clicked, I need to ask these are for two numbers now. If you'd like to. I'm going to give you this file, so it's up to you.
Well, maybe I'll just open a new one so that way I can refer back.
Yeah, that works. Let's see. That might be helpful for the next question on the next slide that I'm going to give you. Anyway, so all right, when the green flag gets clicked, I would like to, all right, first of all, I want to make two variables, or really three, n1, n2, and out, because I want to mess with things. So, all right, let's rename the default variable like n1, make another one, n2, make a third one, out. And let's have them all visible in some nice order. You can drag them around. I'm calling them n1, n2, and out. But you can pick whatever you want.
I know.
So that's that. And then, all right, I got to get two values from the user. I'm getting a value, putting it into n1, and getting another value, putting it into n2. So let's do what we just did before with an ask block. Ask like enter n1 and wait. And then like place that value that we got back from answer into n1, and then do the same thing for n2. So I'll duplicate this, right-click, duplicate, enter n2, and wait. Like change this to n2, set n2 to the new answer that we just got from this ask block. And so now after this, after I run this code, it's like 2, 7, you'll see that they got set. All right, so that's how I'm setting those variables. And now I want to do that process. I want to repeatedly, until n1 is greater than n2, do all this. All right, so let's make it happen. Let's be like, repeat until block down here in control. Repeat until n1 is greater than n2. Then I don't have any numbers to put into out anymore. I'm finished. Repeat until n1, because n1 is supposed to be the smaller value. Once it gets bigger, we're done. Repeat until n1 is bigger than n2. The process of, well, I need to set out to some fancy thing. I need to add n1 into out. All right. Set out to itself plus n1. So let's get a plus operation. Itself plus n1. And then I want to increment n1. So I have like, I first added the 2 into out, now I want the 3. That needs to be the next thing, so I need to increment n1. So let's change n1 by 1 and keep doing this process. I forgot to initialize out again. What should it be at the start? Because I'm adding stuff into it. It's got to be 0, yeah. So set out to 0 at the very beginning. The default value is 0, but if you run this program a second time, you do want to clear out. For sure. All right, so that's going to be the process, and let's see if it works. All right, enter n1, 2, enter n2, 7, and watch it. Well, it went very fast. Immediately it got 27. Let's watch it work by adding a wait block. 2, 7. And you can see that it's putting the 3 in, putting the 4 in, putting the 5 in, adding it into whatever's there, putting the 6, putting the 7, 27. Now n1 is 8. That stops our loop. And again, we can have the scratch cat like shout out the answer. Say out for 2 seconds. Something like that. Oh yeah. So do you see how we went from a problem statement? We thought about the inputs. We thought about the outputs that we need to give back. Like this is our output at the very end once we've computed the answer. And we've got it working. Okay. And so 27 for this particular answer. Are there any questions about this code?
2 seconds. What did I go for after 2 seconds? Oh.
All right. So again, we might have a problem. Like, what if n1 is bigger than n2? Like the user asks us to like add up all the numbers from 7 to 2 in that order. We're going to skip this loop because n1 will be bigger than n2 immediately, and we'll just say 0 because that was the initial value of out for 2 seconds. So maybe there are no numbers between 7 and 2 in that order. Maybe that is the right answer for this particular problem, but it is up to you. Okay?
Yes, I did it.
Nice. So if we're happy with this one too, I will take screenshots of both of these, but I have a problem for you guys. I'll give you some time to think about it, but I'd like you to try now. So here is your problem statement. I'd like you to make a program that asks the user for some number that's positive. You can assume it's positive. And then have the scratch cat count from 1 to that number. So here in this example, I'm typing in 10, and the scratch cat's counting up from 1 to 10. See what's going on there? So try to think about what's the input? What am I getting? What am I trying to output? It's like a lot of outputs, right? Depends on the number you're given. And all right, what's the main problem that you're trying to solve? Printing in this way. Is there any potential issue that you might get? Maybe if the user was not trustworthy, you might have to worry about the value that you're given. But you might be okay if you trust them, if you trust yourself. So that's the problem. I want you to try that for a little bit, and I'll give you the code that I just wrote. Are there any questions about the question?
Is there any difference? Like, we haven't changed the code by chance?
Well, it's got to be brand new code. It's going to be not similar to anything I just did, but slightly still. You're going to be counting. We counted in a few of our programs.
Yes.
So there's that code, and then let me show you the one I just wrote before that. It might be more similar to this first one that I wrote, because we're only using one variable and it's changing. But here are tiny versions of both of those programs. Do we understand the assignment? And here's what the output should kind of look like. Any questions? All right, take a few minutes and try this. It's good practice. Yell at me if you have any questions while you're doing it. So you're getting a number, right? You're getting a number from users. That's very similar to the first problem. What do you have to do with that? You might have to change it. Or you can use that to what will you call that number that you start with?
1. Would you call that 1?
Or actually, you might need two variables, right? Because you have one that starts with 1 always, and then the other one is the number that you want to go up to. You need to remember that somewhere. So I think you're going to need two variables. So what are you going to be looping to? You're going to have to repeatedly, you're starting with 1, print the 1, then it's got to be 2 next. Then it's got to be 3 after that. So maybe it's printing, incrementing. That's the body of the loop. And then when are you done? Because assuming you're doing all that, and you're making a variable, you're incrementing it, printing it, you're trying to go up to 10, for example, you're saving that somewhere. Once you've incremented it to 11, you don't want to print that 11. So maybe that's what's going to stop you. Once that value that you're working on to do your printing with looks like it's bigger than the last number you wanted to see, that should stop your loop. Repeat until it gets bigger. So something like this one. I think that's all the hints I can give you. And do help each other if you are stuck. Interesting. Cool PowerPoint. All right, take a couple more minutes, and then I don't know. Do you want to see an answer from me, or do you trust that you can figure it out if you're given more time?
Answer.
All right, I'll show you. I'll show you my way in a couple minutes.
That's just weird than 0.
All right, that's my 5-minute timer. Are there any questions that came up while we were trying that? Did it make enough sense? Maybe we just needed more time to complete it, but like the ideas were there. So here's how I might think about it. Like I'm getting a number from the user. Like I want to count up to, I'll call it n maybe, counting up to 10. And then like the first number I want to show is 1. It has nothing to do with 10 yet. So maybe I need another variable, like counter, I'll call it counter or something. Start it at 1. Then print the 1, make it 2. Print the 2, make it 3. Print the 3, make it 4. All the way to print the 10, make it 11. Now it's bigger and that should stop things. That's kind of how I might think about it. Does that strategy make enough sense?
Yeah.
So let me quickly do that. I think I saved both of these. Did we do attendance, by the way? I will stop that in just a minute. So if you did not do it, go and do it. All right, lightning mode. When the green flag gets clicked, ask the user for a number. What do you want me to count up to? What do you want me to count up to? Question mark. We get that answer back in the answer variable. We make a new variable so that we can, I guess technically we never have to ask again, so we could keep using answer, but it feels better in my mind to make a new variable and just put it there. Orange is cooler. So set n to answer, and then also like I need the first thing. I need to print 1 first, and I'll call that counter. I'll put the 1 into counter. That's the first thing. Well, it's just a variable that's going to count up. That's why I'm going to call it counter, but you can call it anything.
Okay.
Yeah. So set n to answer, set counter to 1, and then just repeatedly until like counter gets bigger, and I don't want to print what its value is now, but well, it's still nice and small. Once it's smaller than n, keep going. Print it out and increment it. So repeat until counter gets too big to print. I don't care about its answer anymore. Repeat until counter is larger than n itself, because once it gets past like 10, once it becomes 11, I don't want to print 11, I want it to go up to 10. So repeatedly print counter and increment it. So where is it? Say, how about for like 0.5 seconds, say the current value of counter, and then change it by 1. Something like that. So here we go. What do you want me to count up to? 10. There it goes. 1, 2, 3, 4, 5, 6, 7 is making it bigger. 9, 10. Counter does become 11, and that's what stops the loop. We see that? That's kind of how I might think about it. Any questions about this example? Did we get it? You didn't even need me to talk about it? All right. So I'll save that so you have it. What next? So I just want to teach you just the last pieces of Scratch that we haven't learned yet, in case you want to use it in your last programming assignment on Scratch. So I think because of the things you filled out at the start, we might not have enough time for this one. So I'm going to scrub it out just tentatively. We might come back to it if we have time, but I'm going to show you how to make your own block in Scratch. And this is a good example of it anyway. So let me reopen our Pong program. That was, I assume, from last lecture. So let's, last programming lecture. So let's see if I can open that up real quick. Where are we? Lecture 8. I assume it was the last thing we did. Yeah, so there's Pong. And notice, like, it's beautiful, but the ball is bouncing weird. Like, it's doing a 180. That's a problem. And then also, it took so much effort to be like, if we're touching the paddle, then bounce off. When we had this nice if on edge bounce for the other idea, right? That was already implemented for Scratch. Wouldn't it be nice if we had like an if touching paddle bounce block? Because then we wouldn't have to put this ugly thing right below it. We can do that. We can make our own block that just like is called this if we're touching the paddle, bounce off of it. Isn't that beautiful? Let me show you how to do that. So this is the last piece we haven't been in Scratch. It's down here in My Blocks. You can click Make a Block. Make a block, and I want to call this if touching paddle bounce. And now it exists. And it made this little define piece up here, which I'll talk about in a second, but instead of this code being down here and all ugly, I'll put it up here. I'll attach it to that, and I'll show you why in a second. And then, look at how clean this becomes, this program. It's like, all right, forever, this is the balls program right now, forever, like, pick a random spot, pick a random direction, and start moving in that direction. If you're on the edge, like bounce off, there it ran that one. So if you're on the edge, bounce off, bam, it did it. But if you're also touching the paddle, bounce off of that. Do you see how beautiful this forever loop becomes if we make our own block? And now all we have to do is define what it means to run this block. We have to put code inside of it. That's what we're doing when we make a block. We have to say what it means to run this block, because we made it. Scratch has no clue what we're trying to do. So that's what happens when we make a block. It creates this define thing up here, which is kind of like an event. This and any code below it that's connected runs whenever our custom block runs. It's like the implementation of that little piece of that block. All right. So if touching paddle bounce, the second Scratch tries to run this, it'll jump up here and run whatever code we put here, which was the real code to like if you're touching the paddle, bounce off. You see that? But this is nice. We can put it up here and hide it away and look at this pretty code down here. And if we ever need to change how the ball bounces off the paddle, then we can deal with this code up here. But until then, like, this is so easy to understand. Like, ball, move yourself. If you're on the edge, bounce off, and if you're touching the paddle, bounce off of it. Isn't that beautiful? I love it. So, any questions about that idea? You can make your own block, but that means you have to say what happens when it runs. And it's going to be repeatedly run. It's just going to keep on jumping up here, running all that code. But it makes it easier for us to think about things. Right? That's kind of the goal with programming, and eventually we'll get into Python and do this too. But like, the goal is we have a problem and we want to like break it down until it's small enough, little bite-sized pieces, until like it's small enough that we can solve each piece. Break down problems. Problems into smaller pieces. Until those pieces aren't scary anymore. So it's like, I didn't know how to do this, but I'll make this block and figure it out later. That's kind of how you do it, from the top down. And so in Scratch, the pieces become blocks. That's kind of the goal. So, all right, that's the if touching paddle bounce block. And then I promised you to do it right, because like when the ball comes into the paddle, it should not do a 180, right? That was weird. It didn't look right. Bam, shouldn't have done that. So, okay, let's think about this. Let's reprogram this the right way. So here's our paddle. We got the ball coming in. If it's coming in this way, it should bounce off this way, right? That's the normal way to do it. If it's coming in from the bottom, it's coming in this way, it should bounce off this way. If you think about this long enough and like remember math, then there is a 90-degree angle here, and that could be important. But let's kind of like run it in Scratch. So here's my ball. Here's its direction. If it's coming in this way with like negative 130, I want it to bounce off. It's coming in this way, that direction. It's bounce off that way. So what is that? What's that angle as far as Scratch is concerned? It's like, go over here. Oh, it's positive 130. Cool. So if it's coming in negative 130, it should bounce off positive 130. That kind of makes sense. If it's coming in straight at me, negative 90, it should bounce off straight to the right, positive 90. Ooh, that might be a pattern. If it's coming up at me, like, I don't know, negative 50, it should bounce off that way, which is positive 50. So the makers of Scratch were very nice. They made it with Pong in mind. And if we just take our direction, whatever it is right now, and negate it, then the new direction of the ball will be the correct one. That's the goal, right? So don't point in direction plus 180 when you bounce. I would like you to point in direction, whatever your current direction is, times -1, right? Negate itself. Negate yourself, please. That will do it right. Bam. Okay. And so now, every time we are in this loop, that's a bad start of the game. Every time we're in this loop, we're always constantly asking, are we touching the paddle? If so, bounce. And it's going to keep running this code. That's even worse. There we go. There it goes. It's going to negate the direction, and apparently that's the right one. So you can watch it change down here at the bottom, too. It's like -1, -71, +71. Yeah. So that's a complete Pong game now. And remember, if you lose, it figures that out too. Any questions about that? So let me save this so that you can have the real Pong now. Finally complete. But that's how you make your own blocks. It's just code that runs whenever you have to say what it means to run this block. And we put that up here in the define part. Are we good with that?
Yeah.
That's kind of the last piece of Scratch that I haven't told you yet. In the remaining time, I would like to go back to that idea of state machines that we talked about a little bit. I never actually implemented one. I'm going to implement one in Scratch. I think, in theory, there's enough time. So let's do it. Let's make a divisible by 5 state machine. And we're going to write a program to do it. All right? So let's make a state machine. Let's pretend that the user is going to type a number to us 1 digit at a time. So like they're going to type, like they intend to type this number, like 51,080. And it's our job to figure out, like they're going to type it 1 character at a time, the 5, then the 1, then the 0, then the 8, then the 0. And it's our job to figure out, like, okay, now it's multiple of 5. All right? So divisible by 5, another word for that is a number is a multiple of 5. And we can do this. We can solve this problem with the state machine, surprisingly. Let me kind of show you how. If I give you just a bunch of numbers, like 51, 105, 117, or like 120, and then 121, like, how do you know, like, this is a multiple of 5 and this one is? Just by looking at it, and these two are not? Somebody tell me. Like, as humans, how do we look at a number just and read off whether it's a multiple of 5? Look at that last digit. That's all. Just the last digit. If it's a 0 or a 5, it's automatically a multiple of 5. There's no other option. Yeah? We can make a state machine that reads a digit at a time of a number and figure out if it's divisible by 5. Cool. So let's do that. So here's the idea. So like we're going to read a digit at a time. We only need 2 states. And so here's kind of what the user is going to do. They're going to type a character at a time, a digit at a time. Like the first digit in the number that I care about is 5. And so right now, it is divisible by 5 because it was a 5 or a 0. And then they'll type 1, and now the computer will think it holds 51. That is no longer divisible by 5. And then they'll type the 0, and now suddenly that's the last digit. Now the computer thinks, like, if they wanted to stop here, it would be 510, and it is divisible by 5. So just keep on checking that last digit. Now you type 8. Now you've built up the number 55,108. It is not divisible by 5 anymore. And then once you type the 0, that will take us into a state that will remember, like, okay, yeah, the last digit was a 0 or a 5. We're good. This is now divisible by 5. So you're building up that number 1 digit at a time. If you do it that way, you can make a state machine. And you can have 2 states. You can be either in, your number is either in the not divisible by 5 state, or the divisible by 5 state. And you start out with nothing, so your start state is not divisible by 5. And then, the second you see, like, the 5 character, you know that the number that you've made up so far is divisible by 5. So if you see a 0 or a 5, you move to the divisible by 5 state, and so now you type the 5, you're over here. But the second you type a 1, you're no longer divisible by 5, and the number you've built up so far. Does that kind of make sense, how I'm building up the number a digit at a time? It's kind of weird. But it's a good example of state machines. If I type anything other than 0 or 5, that brings me back to, like, that was the last digit in my number so far. That might be the last one overall. So if it's not a 0 or 5, it's not divisible by 5. And then once I type a 0 again, like we moved from this state to this one. Cool. It will be divisible by 5 again. Now we've built up like 510. Does that kind of make sense? And now we're over here, now we're over here, we're divisible by 5. We see an 8. Now we're no longer divisible by 5. But then we see a 0. We're in this state. We think our number is 5,108. We see the 0. Oh man, we move again. We're in the divisible by 5 state. So that's a state machine. And like if you see, like if the number that's typed is like 55, you stay over here twice. You're still divisible by 5 if the number that you saw last, that digit was still a 0 or 5. And then you remain not divisible by 5. You remain in that state if the last digit you saw is still not a 0 or 5. That is the goal. So that's a state machine that will tell you if your number is divisible by 5 by just looking at the last input, taking a transition based on that last input. All right? And so like maybe you type in the number 11, like you're here to begin with, and then you saw a not 0 or 5 and a not 0 or 5, and so you end up in the not divisible by 5 state. But then if you were to type and make your number 115, you'd move from this state to this one, and now suddenly that number that you've built up so far is divisible by 5. All right? Do you kind of see how it's running on those digits? It's a little weird, but it is the best example I know of a state machine that we can program. So that is the idea. Okay, yeah. So now the question is, how do we turn this into code? Like, how do we implement the state machine? We have to ask the user for a digit at a time, and then we have to like run it in the state machine. What does that mean? So the secret is, like, you can't like program this in any normal way. Like, you can't make circles and things in Scratch. What you have to do is just like remember what state you're in. So like, we'll make a state variable, and we'll set it to whatever state we're in. Let's keep track of it that way. Let's be like, all right, if we're ever in the not divisible by 5 state, and we should be to start, we're going to use the number 0 to represent that. And then if we ever transition into the divisible by 5 state, let's use the number 1 to represent that. We can change it. So we can make this state variable change, and that will be how we remember that we moved throughout the state machine. And just like look at the state variable, look at your input, how do I go to the next state? That's how you implement a state machine. It's like, given your current state and the input that you just saw, which transition do you follow? That one or that one, depending on where you are. Okay, is that kind of coming together in our minds? Let me implement it for you. It's very interesting. And then I think I have one last question for you. You'll make your own state machine, and then I'll give you your last assignment. So, all right, I'm going to make a variable that keeps track of what state we are in. So I'll call it state. And the start state of this state machine is the not divisible by 5 state. And I'm going to use the number 0 in the state variable to represent that idea. Okay? So I'm just using a number to represent some big idea of where we are in our state machine, which is interesting in itself. So at the very start, clear out the state machine. We are in the not divisible by 5 state. That's what that means. This is not divisible by 5. 0 means not divisible by 5. And then we want to read a digit at a time. So we're going to just like repeatedly ask, what's the next number? Enter the next digit of the number. And then we'll use that, like this is forever, the number could be infinitely long. Ask the user for the next digit. And then depending on what state we're in and the digit we saw, we have to move. So like if we're in this state and we saw a 0 or a 5, we have to change our state to 1. Because now we've moved to the other state. Or if we're in this state and we saw something that's not 0 or 5, we keep our state set to 0 because we stay there. So that kind of makes sense how we're using a variable to keep track of where we are. This is very complicated, but a good example, I think. So ask for the next digit and wait. And now I have that next digit sitting in the answer variable. And so now, based on where I am, based on what state I'm in, I need to move this machine around. So if my state is equal to 0, then I know I am in the not divisible by 5 state. It's equal to 0. And if that's not true, then I'm in the other state. So if state is 0, and I saw like a 0 or a 5 as my answer, that's the next digit that I got, I need to transition. Okay? So if state is 0, and I saw a 0 or 5, so it's going to be if within an if. So if state is 0 and answer was 0 or 5, that's how you implement this particular transition. Do we kind of see that? It's a little weird. Yeah. So that's how you do that one. And similar things are true for the others. And I know that we got a little offset at the start of class. So I'm going to just like transition to the complete version of this program real quick so that you can see it working, because we are running out of time. So, all right, F23 code from class. Let's do S23 code from class. Same lecture. And I believe it's going to be maybe this one. Let's try. Yeah, cool. So this is the complete version of that. So enter the next digit and wait. If the state is 0, compare it with answer. So here's what's going on. Sorry, it's got to be very small. If the answer is 0 or 5, then that means set the state to 1. We've transitioned. Otherwise, if that's not true, we were here and we didn't see 0 or 5, so we should stay in this state. So set state to 0 again. All right, so that's the inner if-else. And so if the state was 0, we were here and we just transitioned in all the ways that we should. Otherwise, if that wasn't true, we must have been here. State must have been 1. We were in the divisible by 5 state. And, all right, if the answer is 0 or 5, we stay there. If the answer is 0 or 5, keep state at 1. Otherwise, if we were here and we didn't see 0 or 5, move state back to 0 because we needed to transition this way. That's the goal. And so this is the code. Let me zoom out so you can see it all. But that is just what you do forever. Start your state at 0. Enter in, like, the number, what were we doing, 51080, 5, all right, now I'm in, it is divisible, the number 5 is divisible, 51, that's not divisible by 5, that's 51, 0, 510, that is divisible by 5, it's moving around, and then it's 5108, we are not divisible by 5, 51080, that last digit was a 0 or 1, we implemented the state machine, and we end up in the right place. Yay. So, are there any questions about that idea? This is a great program to study, I think. So, like, there's an if and another if inside of it, because it's like, depending on where you are, now, like, which input did you get? There's 2 questions to ask at each time. That's the goal. And so I've made some helpful comments here, like this is running the state machine in the not divisible by 5 state, this first one. All this if else, and then this one is running the state machine when it's in the divisible by 5 state, this whole else block. There. So that's a fun one, I think. So let me save that so you can look at it later. Any questions about that? Pretty cool. So we are kind of running out of time. So I want to do this last idea, this question with you. If I didn't get evaluated during this lecture, I would have just had you try it. But here's the same idea applies to make like a divisible by 2 state machine. So can you think of like how you know that if you're trying to build up a number a digit at a time, like how do you know that like 1 is not divisible by 2, but 12 is, and 123 is not divisible by 2, but 1,234 is? How can you look at this number and know that it's divisible by 2? Similar to how you can look at a number and notice that it's divisible by 5. Like, how do I know that this is a multiple of 2? What are our thoughts? It's a midterm week for a lot of us, and it's just been too long. We wish it would all end. So, another word for divisible by 2 is even. How do I know that this number is even? This last digit, right? If it's an even number, the whole thing's even. Yeah, if it ends in 0, 2, 4, 6, or 8, the whole darn thing is even. Or if it's 1, 3, 5, 7, or 9, that's the last digit, then it's odd. And so you can build a state machine like with, was the last number one of these or was it one of these? And transition between it and read a digit at a time and get the right thing. Okay? So that's how you can kind of build that other state machine. Any questions about that? And I believe that you could do it in Scratch if given enough time. If we are happy with all that, any last questions about this? Because that was the last slide. That was all of Scratch that I want to show you. Yeah, question?
What is our program?
Oh, yeah, I'm about to tell you that. Don't worry. Yeah, we got 5 minutes. That's where I'm going if we didn't have any questions. So, all right, your next programming assignment and the last one on Scratch will be due week 9. And because it's the last one, let's go out with a bang. Here you go. Make whatever you want. You can make a state machine if you want. But please make a program of your choosing that doesn't like copy something we already did in class or something like that. make it unique and cool, but here is the requirement. You can implement whatever you want as long as you complete the following requirements. As long as your program has 3 key press events, like maybe you're moving around when up is pressed, up, down, left, right, things like that, or space to jump, stuff like that. You must also use at least 2 conditional blocks, so those are like your if then else or if then, things that take some Boolean condition that gives back true or false, one of those pointy blocks. You gotta have 2 of those. I was like, check if the ball is touching a paddle. That's one thing. Like, was that true? You must also have 2 loop blocks, so like a repeat until block, or a forever block, or repeat exactly 10 times block. At least 2 of those, like we were doing for Pong, like move in your current direction forever with the ball. And then finally, you just can't copy exactly something that we did in class, but you can totally build off of it. Like, take Pong and make it like 4-player Pong with different key combinations to move each paddle, something like that. I don't know, but it's up to you. And yeah, upload a video and explain your code, and that could be your program. Yeah, whatever you want. This will need a bit of a longer explanation because I have no clue what you're writing, right? I have no clue what program you're making. It's up to you. So expect to talk about it for a little while longer than you usually do. But that is about all that I have to say about that one. So that's for Scratch. That's your assignment. Any questions about that one? All right, if you are a programmer, if you've taken a CSCI class already, then here is your alternative assignment in the Racket programming language. So read these chapters and do these 3 exercises. And remember that I can give you something custom if you would like to do something else. But this will be this last time that I give 2 separate assignments as well. But any questions about this one? Same idea as before, I think. Yeah. So from now onwards, you programmers will be doing Python assignments with the rest of the class. So after I teach us Python,
What's Python?